So, what in the previous lecture we have discussed about the types of power plants. We have classified the hydroelectric power plant based on the quantity of the water available, head of the water, nature of the load. Okay, so when you are going to classify the power plant based on the water available, we are going to classify in the three types. One is runoff river power plants without pondage, in which we are not going to store the water. Simply, when the water in the river is flowing, at that time we are going to generate the electricity, and that water is continuously flowing through the river. In second case, we are going to just store the waters by constructing a small dam over there, or by just blocking the waters over there. So that is called as the runoff river plants with the pondage. And third one, and most commonly used all over the globe, is the reservoir plant, in which you are going to construct the dam, in which I am going to store the waters in the large quantity, in the bulk quantity, and as and when required by me, I will just release the water to generate the electricity. So reservoir plants can mostly seen in Maharashtra and most of the places. Then based on the head, okay, so if the water head is less than 30 meters, then these are called as the low head plant. If the water head is in between the 30 meters to 100 meters or 300 meters, then these are called as the medium head plants. And if the water head is more than 100 meters or 300 meters, then these are called as the high head plants. What is head? Head is the level of water, top level of the water from the base ground level, reference level. Okay, and base, then we are classified the plant based on the base load, peak load, load on the system. So these are called as the base load plant, peak load plant, pump storage, hydroelectric power plant. Base load plants are continuously running 24 by 7, and they are of very large size. Peak load plants are running only for few hours per day, or basically on weekends or something. Okay, so they are not continuously running. If my hydroelectric power plant is continuously running 24 by 7, then it is called as the base load plant. If my hydropower plant is running only for few hours per day or few hours per week, then it is called as the peak load plant. And third plant is called as the pump storage hydroelectric power plant. In pump storage hydroelectric power plant, what you are going to do? During peak hour, we are generating the electricity, and during off peak hours, we are going to use the electricity to lift the water from low reservoir to the higher reservoir. So in case of pump storage power plant, we have two reservoirs, two dams. One is at top level, one is at height, and second is at depth. Okay, so if I want to generate the electricity during peak hour, or when it is required, so at that time I am releasing the water from the higher reservoir. Okay, that water flows through the turbine. Turbine will rotate, which is connected to the alternator. Alternator rotate and generate the electricity, and that water is stored into the lower reservoir. Now, during night or when my load on the system is less, at that time I am using the electricity from the grid to rotate the alternator as a motor and turbine as a pump. Remember over here, during off-peak hours or when the electricity demand in my system is less, at that time in pump storage power plant, we are using alternator as a motor and turbine as a pump to lift the water from lower reservoir to the top reservoir or the upper reservoir. So these are the various types of power plants we have discussed in the previous lectures. Now, then today we are going to discuss the most important things in the power plant, that is called as what you are going to say, it is a turbine. Okay, so these are the various types of power plants. Now their power plants are again some differences are there. The differences we are not discussed in the last lecture. So what is the basic difference between the base load plant and peak load plant that we are going to discuss? So in case of base load plant, the base load plant supplies the base load of the load core known as the base load plant. Okay, the power plant which supplies the base load of the load core is called as the base load plant, means which is continuously running. Base load means what? The load which will remain in the system for 24 hours. Continuously for 24 hours is called as the base load. बेस लोड म्हणजे काय? माझ्या सिस्टीमवरचं कमीत कमी लोड जे 24 तास कंटिन्यू असतं सिस्टीमवर, त्याला म्हणतो आपण बेस लोड. व्हॉट इज पीक लोड? द पीक लोड प्लांट विच सप्लाइज पीक लोड ऑफ द लोड core is known as peak load plant. Now what is meant by peak load? Peak load is occurring only during few hours per day. Okay, 4 hours to 5 hours or 3 hours. पण फक्त कंटिन्युअस नाहीये ते, दिवसामधल्या काही वेळा करतात जे लोड येतं जास्त प्रमाणातलं, दॅट इज कॉल्ड एज द पीक लोड. Base load plant capacity is always high. Okay, so base load plant capacity may be say in the megawatts. Base load plant capacity is the in megawatts, that may be 100 megawatts or some like 50 megawatts or 200 megawatts, 300 like that. And peak load capacity is basically low. They have the lower generating capacity. It has few megawatts, 2 megawatts, 4 megawatts, 10 megawatts, means it's up to tens of megawatts only. Then pump capacity for base load plant is high and peak load plant is low. Working hour, if you are going to consider base load plant, as we have discussed, base load means the load on the system which will occur 24 hours per day. That is called as base load. So it will have to work 24 hours. Okay, and peak load plant has to work only for few hours during the peak load hours. Now, if I am going to compare the cost of generation, the base load plant cost of generation is high, and in case of peak load plant, in case of base load plant, the cost of generation per unit is less because my cost is divided over the number of units, 24 hours. How many units are going to be generated through the 24 hours in which my cost is divided, so the cost per unit is less. Okay, in case of peak load plant, my cost per unit is very high. Okay, so basically in the base load plant I will take 2 rupees per unit. So in case of peak load plant, that may be 3 rupees, 4 rupees or 5 rupees also, depending on which plant you are going to select over there. Starting time for base load plant should be more, but for peak load plant it should be as small as possible. Okay, it should be hardly in few minutes. Okay, but in case of base load plant, its starting time should maybe, if it is less then it is very good. But in case of thermoelectric power plant, or in case of your nuclear power plant, the starting time is in hours, that may be 12 hours to 48 hours also. So basically the starting time of your base load plant is quite high as compared to the peak load plant. Load factor in case of base load plant is high. In case of peak load plant, it is less. Load factor means what? What is the percentage of the total load which is taken by the system or the plant? Percentage of the total load which is taken by the plant. In case of base load plant, it is high, and in case of peak load plant, it is low. Say if my system 100 megawatt load is there, and if my power plant capacity is 90 megawatt, then most of the load is taken by the base load plant, and only 10 megawatt is there taken by your peak load plant. So it is called as the load factor for peak load plant is less or low. Utilization factor means what? For how long you are using. युटिलायझेशन फॅक्टर मध्ये काय आपण ऑलरेडी डिस्कस केलेलं आहे, परत रिवाइज करतोय फक्त, बिकॉज दिस इज कॉमनली आस्क इन द इंटरव्ह्यू ऑल्सो आणि एक्झाम ऑल्सो. युटिलायझेशन फॅक्टर मीन्स व्हॉट? फॉर हाऊ मच टाइम आय एम युझिंग दॅट प्लॅन्ट. ओके, 24 तासापैकी किती तास मी तो प्लॅन्ट यूज करतो त्याला युटिलायझेशन फॅक्टर होतात. बेस लोड प्लॅन्ट आहे ना, आपण कंटिन्युअस यूज करतो 24/24. So it is utilization factor is nearly 100%. But in case of peak load plant, we are using only for few hours per day or few days per week. So its utilization factor is less. And base load plants large capacity, they may be hydro, they may be thermal, they may be nuclear station. And peak load plants may be small capacity. That may be hydro, pump storage hydro, gas, diesel. These are the peak load plants over there. Okay. Then next point that we are going to discuss over here is what? Okay, runoff river plant versus pump storage power plants. Okay, we have discussed all this in the previous lecture. Now what is the basic difference? What are the differences between runoff river plant with pondage and pump storage pond? So in case of runoff river plant, one water reservoir at headrest means at upper level. रनऑफ रिव्हर मध्ये काय तुमचा एक वॉटर रिझर्वायर असतं ते हेडरेसला, आणि पंप स्टोरेज मध्ये तुम्हाला दोन वॉटर टँक लागतात. एक असतं अप्पर लेवलला आणि एक असतं बॉटम लेवलला. मीन्स हेडरेसला एक टँक आणि बॉटम लेवलला एक टँक. So alternator converts mechanical power into electrical power in case of runoff river power plant, and in case of pump storage it will convert mechanical power into electrical power. Okay, but when I want to use as a pump, at that time it will convert electrical power into mechanical power. So pump storage power plants have constructional difference, means the alternator turbine pair which is used for the pump storage power plant is of different types. Okay, which can be the alternator may act as a motor also, and turbine may act as a pump when it has to lift the water from lower reservoir to the upper reservoir. So in case of pump storage power plant, we will get both conversion, mechanical to electrical as well as from electrical to mechanical. Okay, in case of runoff river plant, turbine converts mechanical power. Okay, And in case of reservoir power plant, turbine converts mechanical power as well as it will convert electrical power into mechanical power. It will pump the water from lower level to the upper level also. Okay. Then next, capital cost per megawatt cost is less as only one dam is required in case of runoff. And in case of pump storage, I require two dams, one at the top level and second is at the bottom level. So if I require two dams, so definitely my cost will be more over here. Then plant capacity. In case of runoff, it says the more capacity, and in case of pump storage, it has less capacity. Because what I have to do, definitely I have the scarcity of the water over here. पाण्याची ऑलरेडी कमतरता असल्यामुळे मी खूप मोठ्या प्रमाणात डॅम कन्स्ट्रक्ट करू शकत नाही. सो इट्स कॅपॅसिटी इज समवॉट लेस. इट इज हार्डली टेन्स ऑफ मेगावॅट. सर्ज टँक. सो रन ऑफ पॉवर प्लांट नीड्स सर्ज टँक. And in case of your pump storage power plant, as the capacity is low, so there is no need of the surge tank over here. Application: the runoff river plant may be used as a base load plant, and base load plant as well as peak load plant. Runoff river plant can be used as a base load plant as well as peak load plant, but pump storage power plant can only be used as a peak load plant. They cannot be used as a base load plant because they have to work 24/7 hours. Then only it is called as base load plant. If it is working only for few hours, then it is called as the peak load plant. Okay, so these are certain differences between these two. Now, the things that we need to just concentrate in today's lecture is what? Or types of turbine. There are different types of turbines. The turbines used in hydroelectric power plant act as a prime mover for generator. Okay, आपण जे हायड्रोइलेक्ट्रिक पॉवर प्लांट मध्ये टर्बाइन यूज करतो ते काय म्हणून वर्क करतं? जनरेटर करता प्राइम मूवर. प्राइम मूवर मीन्स विच विल प्रोवाइड्स द मेकॅनिकल मोशन टू द जनरेटर. Okay, then only my generator will convert mechanical energy into electrical energy. So my turbine will convert kinetic energy of the water into mechanical energy, which is coupled to the generator. Okay, and that's why that turbine is also called as prime mover. The second name for the turbine, in most of the cases these are called as the prime mover of the generator. Now these turbines are classified into two types of turbine according to the type of flow of water. Okay, तुमच्या वॉटरचा फ्लो कसा आहे त्याच्यानुसार टर्बाइनचं क्लासिफिकेशन होतं. एक्सियल. Okay, if the water is flowing along the axis of the shaft of the machine, then it is called as the axial flow turbine. Okay, second is radial flow turbine, axis along the radius. Okay, radius च्या axis मध्ये जर होत असेल तर त्याला म्हणतात radial flow turbine. Axis along the tangential direction. Okay, so whether my flow of water is along the axis of shaft ची डायरेक्शन आणि माझ्या वॉटर फ्लोची डायरेक्शन सेम असेल, सो these are called as the axial flow. ओके, सेकंड केस मध्ये तुमच्या फ्लोची डायरेक्शन आणि रेडियसची डायरेक्शन जर सेम असेल, सो these are called as axis along the radius. And third one, if my flow direction is tangential means what? You have drawn the circle आणि सर्कल करता एक लाईन इथे येते, that is called as the tangent. If it is tangential, then these are called as the axis along the tangential direction. Then according to the energy conversion, okay, according to the action of fluid means when it has to convert the kinetic energy into mechanical energy, then these are called potential energy into the kinetic energy, then these are called as impulse turbine and reaction turbine. Okay, so mostly we are going to discuss on this one, impulse turbine and reaction turbine. So basically in impulse turbine, what is going to be happen? In impulse turbine we are going to use the nozzle. ओके, नोझल यूज केला जातं इम्पल्स टर्बाइन मध्ये. त्याच्यामध्ये तुमचं मॅक्झिमम एनर्जी कशामध्ये कन्वर्ट होतं? कायनेटिक एनर्जी मध्ये. प्रेशर गो ऑन इन्क्रीजिंग. सो फर्स्ट वी विल डिस्कस अबाउट द एक्सिस. सो क्लासिफिकेशन ऑफ टर्बाइन अकॉर्डिंग टू द type of flow of water. The first one is what? Axis along the shaft of machine. Okay, the machine having flow of water along the axis are called as axial flow machine. ओके, तुमचा वॉटरचा फ्लो आणि शाफ्टचा फ्लो जर सेम असेल तर त्याला काय म्हणतात? एक्सियल फ्लो टर्बाइन. सो इट इज कॉल्ड एज द एक्सियल फ्लो टर्बाइन. सेकंड, एक्सिस अलॉंग द रेडियस. इफ द एक्सिस ऑफ योर वॉटर is along the radius, the machine in which the water flows along the रेडियसच्या जर along मध्ये फ्लो होत असेल तर it is called as the radial flow turbine. That is called as radial flow turbine. And in third case, the axis along the tangential direction. So in that case, the turbines are called as the tangential flow turbine. Okay, my direction of flow of water is tangential to the turbine. Okay, then it is called as the tangential flow turbine. Mostly we are going to use these two, axial flow turbine and radial flow turbine. Then next one is according to the action of fluids. So such type of turbines are used at high heat. Impulse turbine. In case of impulse turbine, what you are going to do? In impulse turbine, the entire pressure of water. Remember over here. Impulse turbine मध्ये काय होतं? वॉटरचं जेवढं काही प्रेशर असेल, entire pressure of water is converted into kinetic energy in a nozzle. Impulse turbine मध्ये आपण nozzle use करतो and that nozzle will converts the entire pressure of water into kinetic energy. Means your kinetic energy, sorry, pressure energy is converted into kinetic energy 100%, means maximum. Okay, all the pressure energy is converted into kinetic energy inside the nozzle only, with the help of nozzle only. The velocity and the velocity of the jet drives the wheel. Okay, and whatever the velocity, so when you are going to convert the kinetic energy into, sorry, pressure energy into kinetic energy with the help of nozzle, definitely the pressure will increases. Okay, so that velocity of that water, the velocity of the jet will drive the wheel, and when that comes on the bombarded on the wheel, okay, or the buckets, then it will apply the pressure, and that causes the rotation of your wheel. The example of this turbine is called as the Pelton wheel. याचं एक्झाम्पल काय आहे? इम्पल्स टर्बाईनचं एक्झाम्पल आहे पेल्टन व्हील टर्बाईन. पेल्टन व्हील टर्बाईन मध्ये बकेट्स असतात. ओके, सो इफ यू आर गोइंग टू सी द पेल्टन व्हील टर्बाईन, इट हॅज बकेट्स. ओके, सो आय विल शो यू द इम्पल्स टर्बाईन. Now this is the example of A, figure A. Okay, so this is the example of your impulse turbine. Impulse turbine मध्ये काय एक नोझल आहे, आणि नोझल यूज केला आपण की नोझल मुळे स्पीड वाढतो तुमचा. सो ऑल द वॉटर विच इज पासिंग थ्रू दिस इज कन्वर्टेड इनटू द pressurized water, or its kinetic energy will be more, and this will fall on the buckets. So when this will fall on the buckets, that will apply a pressure on the buckets, and the bucket will move into the downward direction. Okay, so as this will causes the pressure on the bucket, so that bucket causes the, so the pressure causes the bucket to move into the downward direction, and that causes the rotation, because when the bucket goes down, the next bucket will come over here, and the water jet will fall on this one. So one by one the bucket will go downward, and that causes the rotation of the turbine. So in case of your impulse turbine, example is the Pelton wheel turbine. We have the buckets, okay, and water jet. The water jet is falling on the buckets and causes the movement of the buckets into the downward direction. Okay, so one by one the bucket will replaced by the second bucket, first bucket will be, and the water jet fall is falling on that one, so that causes the rotation of the blades. Okay, so this is your Pelton wheel turbine. So basically such type of turbines are used at high heat. मग आता याच्याकरता तुम्हाला प्रेशर खूप लागतं, कारण तेवढी कायनेटिक एनर्जी. सो नॉर्मली वेन द हेड इज मोर, वेन द हाईट ऑफ द वॉटर is situated which at a certain height, then only I can use the Pelton wheel turbine. Otherwise I have to go for Francis turbine or Kaplan turbine. Okay, so second type of turbine is called as the reaction turbine. Reaction turbines used for low and medium heads. Reaction turbine कुठे यूज करतो आपण? लो हेडला आणि मीडियम हेडला, मीन्स अप टू 100 मीटर, ओके, or 300 meter. So in the reaction turbine, water enters the runner partly with pressure energy and partly with the kinetic. आता रिएक्शन टर्बाईन मध्ये काय होतं की वॉटर जे आहे तुमच्या डॅम मधनं येणार, दॅट एंटर्स द रनर पार्टली विथ प्रेशर एनर्जी अँड पार्टली विथ द वेलॉसिटी हेड. याच्यामध्ये कायनेटिक एनर्जी आहे आणि प्रेशर एनर्जी दोन्ही आलेले आहेत. तुमची वेलॉसिटी हेड पण आहे, एका हायर हेडवरनं येतं, ॲज वेल ॲज इट हॅज कायनेटिक एनर्जी ऑल्सो. The reaction turbines are classified into Francis turbine and Kaplan turbine. So there are two types of turbine. One is Francis turbine, which is commonly used, and second one is the Kaplan turbine. Okay, so this Francis turbine and Kaplan turbine, they does not have buckets. Francis turbine and Kaplan turbine la buckets nasta. Instead of buckets, they what they have? They have the blades. Okay, specially designed blades through which my and runners. त्याच्यामध्ये ब्लेड्स असतात आणि रनर्स असतात. आणि इम्पल्स टर्बाईन मध्ये तुम्हाला नोझल आहे आणि बकेट्स आहे. So examples of your reaction turbine and impulse turbine. So these are the diagrams. Now this is my Pelton wheel turbine, this is my Francis turbine, and this one is my Kaplan turbine. Okay, so in Francis turbine you can see that these are the specially designed blades. Okay, So my water is coming from these water inlet tubes. Okay, through the chambers the water is coming and that will go through the guiding vein. रिएक्शन टर्बाइन मध्ये गाइडिंग वेन्स आहेत. त्या गाइडिंग वेन्स काय करतात, वॉटरला डायरेक्ट करतात. गाइड मीन्स इट विल डायरेक्ट द वॉटर टू फ्लो इन विच डायरेक्शन इट हॅज टू फ्लो, and then through the guiding vein the water is go inside the turbine blades, and then as these blades are specially designed, so their surface area is such that the pressure go on decreasing from from incoming side to the outgoing side, so they will extract the maximum pressure at the entry point only, and this is called as the Kaplan turbine. In Kaplan turbine, you can also see that there are tubes through which my water is coming, volume tubes, and then that will pass through the specially designed blades. Okay, so it is a mixture turbine. It has certain impulse pressure also as well as reaction also. Okay, so basically it is called as the reaction turbine, Kaplan turbine. Now, if we are going to see the diagram of your Pelton wheel turbine, so your Pelton wheel turbine looks like this one. So this is my say penstock through which my water is coming. Then it has a nozzle. पेनस्टॉकच्या एंडला काय केलेलं आहे, आपण पेनस्टॉकचं डायमीटर कमी केलेलं आहे. नोझल मीन्स व्हॉट, यू आर गोइंग टू डिक्रीज द डायमीटर. सो वेन डायमीटर डिक्रीजेस, definitely your speed will increases, or velocity will increases, pressure will increases. Okay, and then again I am going to open and close with the help of spear. Okay, so with the help of this spear gear I am going to open and close the opening of this nozzle. Okay, so what happened here, all the potential energy is converted into the velocity energy or pressure energy inside this, and when this water jet falls on the buckets, so this is my Pelton wheel. Pelton wheel ला काय आपण आहे ना, buckets solder केलेले आहेत, buckets त्याच्यावर fix केलेले आहेत. The buckets may be casted or it may be fixed with the help of nut and bolts. दोन्ही टाईपचे. जर लोअर कॅपॅसिटी असतील तर डायरेक्ट कास्टिंग मध्ये बनवतो, आणि हायर कॅपॅसिटी असेल तर आपण नट अँड बोल्टने फिट करतो. नट अँड बोल्ट इज प्रिफर बिकॉज यू कॅन रिप्लेस द buckets as and when required if some bucket is going to be damaged, and if it is a casting then it is quite difficult for you to replace it once it was damaged. Okay, so ह्याचे buckets आहेत. So when the water is flowing through this one, these water jets make an impact with the bucket, आणि इथे इम्पॅक्ट केल्यामुळे काय होईल, इथे एक फोर्स आलेला आहे. या फोर्स मुळे काय होईल, दिस विल पुश इनटू द बॅकवर्ड डायरेक्शन. बिकॉज ऑफ दिस वॉटर pressure, this bucket will push into the backward direction and it will move over here. So and it will move as these are connected on the periphery of the runner, okay, or your turbine. So these are connected or placed on the periphery of the runner. So when it will move down, move into backward direction, the next bucket will take its position, and that will experience the force. Okay, so as this bucket also experience the force, so it will move down, and one by one the bucket will come over here, and that causes the rotation of this turbine. So when this turbine will rotate, so your kinetic energy is converted into mechanical energy, and this turbine shaft is connected to the shaft of your generator. Okay, so generator also rotate over here, and at which it converts mechanical energy into electrical energy. Now Pelton wheel is an impulse type turbine. We are going to discuss something about the Pelton wheel. पेल्टन व्हील काय आहे की इम्पल्स टाइम टर्बाइन आहे. इम्पल्स टाइम मध्ये काय आहे, इम्पल्स टाइम मध्ये आपण नोझल यूज करतो, and in the nozzle my kinetic energy is potential energy is converted into kinetic energy as well as pressure energy. This type of turbines are used in the high heat application. Okay, हे कुठे यूज होतात पेल्टन व्हील टर्बाइन. सो बेसिकली 19 meters to से 1100 meters जे असतील त्याच्यामध्ये आपण ते यूज करतो. ओके, so its specific speed, if you are going to consider the speed, it is running at only 10 to 40 rpm. त्याचा स्पीड कमी आहे, it will running at 10 to 40 rpm only. It consists of rotor equipped with elliptical buckets along the whole periphery, and if you are going to consider it as a rotor, हे रोटर आहे आणि रोटरवर काय कनेक्ट केलं आहे आपण, बकेट्स आहे, and these buckets are also like the spoons. Okay, if you have seen that आईस्क्रीम स्पून, आपण आईस्क्रीम घेताना जर त्यांच्याकडचे स्पून बघितले, त्याची कशी इलिप्टिकल शेप असतं, याच्यामध्ये when you are going to, the shape is like that one. It consists of the rotor equipped with the elliptical buckets along the whole periphery. पूर्ण रोटरच्या पेरिफेरीवर बकेट्स माउंट केलेले आहे. The Pelton wheel turbine consists of runner, bucket, nozzle, needle valve and shaft. Needle valve it's also called as the say your spear gear. Okay, so the Pelton wheel turbine consists of runner, buckets, nozzle, needle wall and shaft. The buckets are made up of stainless steel. Buckets कशापासून बनलेले आहेत? So buckets of the Pelton wheels are made up of stainless steel, cast iron or bronze material. Okay, so all these materials are anti-rusting material, rust-free materials. Okay, basically because if I'm going to use the water directly on with the material which are rusting, that causes the rusting effects, and over the period of time the my material may get damaged. Okay, so the buckets are made up of stainless steel, cast iron or bronze material. So for low power applications or for low rating we are going to use the stainless steel and bronze, but if the size is more then we may go for the economical reason, cast iron. This type of turbine, one or two jets are used to force the water through the buckets. So in this case we are going to only use one or two jets. For that for what purpose? For forcing the water on the buckets. The nozzles are used to increase the pressure of water flow towards the turbine आणि त्याकरता आपण nozzle use करतो. What is the purpose of nozzle? The nozzle's purpose is to increase the pressure of water. Nozzle ने काय use केलं जाणार आहे? Increase केलं जातं pressure. So nozzles are used to increase the pressure of water flowing through the turbine. Okay, the shaft is flowing towards the turbine. The shaft is useful to mechanical the shaft is connected to the mechanical coupling of the generator. Okay, so it is not useful over here. The shaft is connected to the mechanical coupling of with the generator. The direction of water flow is tangential. If you are going to see here, the direction of water flow is tangential over here. It is flowing in the tangential direction to the this rotor. Okay, so it is the tangential flow direction. Then second turbine, which is used for low power application, so low head application, that is called as the Francis turbine. Okay, and Kaplan turbine. So we are going to discuss first Francis turbine. Francis turbine is a reaction type turbine. Okay, this Pelton wheel is a impulse type turbine. This a Francis wheel का reaction type turbine. Francis turbines are mostly used for medium heat. What is the where you are going to use the Francis turbine? You are going to use for middle heat, 14 to 300 meter. Okay, from 14 meter to 300 motor I am going to use the Francis turbine. The specific speed, if you are going to consider the speed of Francis turbine, its specific speed is 90 to 440 rpm. ओके, जसं आपला पेल्टन व्हीलचा टर्बाईनचा स्पीड जो होता तो 40 rpm पर्यंतच आहे, 40 to 60 rpm at the max. But in case of Francis turbine its speed is 95 rpm to 440 rpm. The Francis turbine consists of outer and inner ring. फ्रान्सिस टर्बाइनला दोन रिंग्स आहे, एक आउटर रिंग आहे आणि एक इनर रिंग आहे. सो द फ्रान्सिस टर्बाइन कन्सिस्ट ऑफ आउटर इनर रिंग ब्लेड्स अँड व्हील. ओके, द आउटर रिंग कन्सिस्ट ऑफ स्टेशनरी गाइडिंग ब्लेड. आउटर रिंग मध्ये काय, द आउटर रिंग कन्सिस्ट ऑफ स्टेशनरी गाइडिंग ब्लेड्स विच आर फिक्स टू द केसिंग. ओके, आउटर रिंग मध्ये गाइडिंग ब्लेड्स आहे. दिस गाइडिंग ब्लेड्स विल गाइड द वॉटर टू फ्लो फ्रॉम युअर पेनस्ट्रोक टू द टर्बाइन. Okay, so these are the stationary guiding blades. These blades are not moving. The inner ring consists of rotating blades. आणि inner ring जी आहे तुमची त्याच्यामध्ये rotating blades आहे, movable blades आहे. The water flow in the Francis turbine is radial in direction. Okay, in case of your Pelton wheel the water flow is tangential. In case of your Francis turbine it's radial. The water flow in the Francis turbine is radial in direction. Francis turbine मध्ये जो water flow आहे तो कसा आहे, radial आहे. Sometimes the draft tube is used for discharge of water into tail race. Okay, so in case of this one we are going to use the draft tube to discharge the water from turbine to the tail race. Okay, so to release the water we are going to use the draft tube. The Francis turbine is of horizontal and vertical type. Okay, so basically Francis turbine comes into configuration, either horizontal configuration or vertical configuration. The horizontal turbines are used for high speed. If my speed is more, then I can prefer the horizontal turbine. Okay, and vertical turbine is used for high capacity. Okay, lower speed and high capacity. So horizontal turbines are used for higher speed, few hundreds of rpm, and in case of your uh, vertical turbine they are used for low speed but higher capacity. The diameter and weight of Francis turbine is less. If you are going to consider the Francis turbine of same capacity with the help of Pelton wind turbine, the Francis turbine has less diameter as well as less weight. So the cost of is this less. Material requirement is less over here. But if you are going to consider the design parameter, the complexity of this one is more, because the blades which are going to use for the Francis turbine have specially designed blades. The blades of these turbines are moved in both direction. Okay, so the blades which are going to be used for the Francis turbine should move in the both direction according to the flow of water, as water is flowing in that way. The higher speed is very efficient type of machine at higher speed. If the speed is more, then the efficiency of this machine will be increases. Or if I am going to operate my Francis turbine at higher speed, definitely it will give me the more efficiency. Okay, so this is the Francis turbine. Francis turbine looks like this one. If you are going to see the diameter go on decreasing, okay, here diameter is more, and as will I will progress it, the diameter go on decreasing, and these are your guiding vanes. Okay, so these guiding vanes are fixed one, and these guiding vanes are rotating one. Okay, and this is your tubes through which my water is coming and flowing through this one. Okay, so this is actually turbine, and these are the tubes through which my water is coming. These are called as the guiding vanes. These are the fixed guiding vanes, and these are the movable guiding vanes, runner. And this is the draft tube. So after completion of the work by the water need to be released into the tail race. So we are going to use the draft tube for releasing the water into the tail race. Now, next type of turbine is called as the Kaplan turbine. So, in construction, the Kaplan turbine is also a reaction type turbine, but it's a constructionally different. Okay, so if you are going to see the location over here, its location is just below this inlet. Okay, and its location is just at the inlet. ओके, वॉटरचा फ्लोचा जो आहे तो त्याच लोकेशनला आहे, आणि याच्यामध्ये जर तुम्ही बघितलं कॅप्लन टर्बाईनला, त्याच्यामध्ये तुम्हाला डिफरन्स दिसतो. The Kaplan turbine is a reaction type turbine. Okay, yeah, Kaplan turbine also uses the draft tube and all these things. So my Kaplan turbine is basically a reaction type turbine. The Kaplan turbines are used for low head applications. As my Francis turbine is used for medium head application, these turbines are used for low head application, 3 meter to 30 meters, and its speed is 550 to 830 rpm. Okay, Kaplan turbines are moving at 500 to 800 rpm. The Kaplan turbine consists of blades, runner, casing, guide blades, guide wheel, draft tube, and shaft. These are some major components of your Kaplan turbine. Kaplan turbine consists of runner, then blades, then casing, guide blades, guide wheels, draft tubes, and the shaft. The Kaplan turbine consists of 3 to 6 blades. If you are going to see, it has consist of only 3 to 6 blades. It does not have multiple blades. Kaplan turbine, in Kaplan turbine, when the water strikes in axial direction. Okay, so in Pelton wheel the direction is tangential. In Francis the direction is radial. And in case of Kaplan turbine, the direction is tangential. Sorry, axial. In Kaplan turbine, the water strike in the axial direction. Okay, so these are the types of turbines which are commonly asked in the exam. The guide vanes are used to control the speed of water. In case of Kaplan turbine, if I want to control the speed of water, if I want to just reduce the energy generation, I need to reduce the speed, so then I have to just use the guide vanes. Okay, change the position of guide vanes, so the speed of control, it will control the speed of water. These type of turbines are higher efficiency at load, all load. Okay, in irrespective of the load on the system, it will give me the better efficiency, higher efficiency. It is used for low head, but to run the turbine, large quantity of water required. Definitely, what happened? I'm going to use at low head, but for running the turbine, it requires more amount of water. More amount of water is required. The ample amount of water is required in this case. The draft tube. The draft tube is useful to discharge the water to trailrace level. The shaft is useful for mechanical coupling between turbine and generator. In the same way, you are going to use shaft. The shaft will connect my turbine to the generator. Okay. Now specification. What are the specification of this reefer? So this question is asked in the exam for 2 marks. Give the specification of Pelton wheel turbine and Francis turbine. So Pelton wheel is the impulse time turbine. It can be used up to head of 190 meters to 1100 meters, and its speed is 10 to 40 rpm. Francis turbine is a reaction type turbine. It can be used for the head of 14 meters to 300 meters, and its specific speed is 95 to 440 rpm. And Kaplan turbine is also a reaction turbine. Its head is 3 to 30 meter. It is the lowest head turbine, and its speed is 500 to 800 rpm. Now, if I want to compare these turbines, so basically Pelton wheel and Kaplan turbine, Francis turbine and Pelton wheel turbine, we need to do the comparison. So in that case, they are going to be compared on certain parameters. The first parameter, flow of water. In case of Pelton wheel turbine, my direction of flow of water is tangential. Okay, and in case of Kaplan turbine, the direction of flow of water is axial. ओके, तुम्ही जर याचा विचार केला तर याच्यामध्ये जी डायरेक्शन ऑफ फ्लो ऑफ वॉटर आहे ती टँजेन्शियल आहे रनरला, आणि या केसमध्ये जी आहे ती ॲक्सियल आहे. इट इज इन ॲक्सियल विथ द रनर इन कॅट कॅप्टन, सुटेबल फॉर हेड अँड लो. So Pelton wheel turbine is suitable for high heat power plant. Okay, and Kaplan turbines are suitable for low heat power plant, very low heat power plant. Construction: the runner rotated in air and no casing is required. So basically in case of Pelton wheel turbine, whatever the runner that is open to the air, so it does not require any special casing. Turbine consists of runner, buckets, nozzle, needle wall and shaft, or runner of made up of cast steel, blades made up of stainless steel, cast iron, bronze, etc. But in case of Kaplan turbine, the runner rotated in fully immersed water, and casing is required. ओके, कॅप्लॅन टर्बाईन मध्ये आहे ना, कॅप्लॅन टर्बाईन पूर्णपणे पाण्यामध्ये असतो. ओके, सो रनर रोटेड इन द फुल्ली इमर्स वॉटर, अँड फॉर दॅट पर्पज इट रिक्वायर्स केसिंग. जर केसिंग नसेल तर ते पाणी बाहेर पडेल. सो इट रिक्वायर्स कम्प्लीट केसिंग ओव्हर देअर. 100% केसिंग इज रिक्वायर्ड. रनर कन्सिस्ट ऑफ रनर, ब्लेड, केसिंग, गाइडिंग blades and guide wheels, and draft tube and shaft. So these are the components of your turbine. Turbine consists of runner, then turbine consists of blades, casing, guiding blades, guide wheel, draft tube and shaft. Runner blades are made up of steel, cast, cast steel, and buckets made up of stainless steel. Okay, so in case of Kaplan turbine, we are not going to use the buckets. So runner is normally made up of your cast steel. So control of water, discharge of the water controlled by nozzle opening. So in case of Pelton wheel, नोझलची ओपनिंग क्लोजिंग वरनं आपण वॉटरचं स्पीड कंट्रोल करतो, डिस्चार्ज कंट्रोल करतो, किती वॉटर रिलीज करायचं आहे. अँड इन केस ऑफ कॅप्लॅन टर्बिंग बाय ओपनिंग अँड क्लोजिंग द गाइडिंग वेन्स और द विकेट गेट्स. गाइड वेन्स त्याला म्हणतात किंवा विकेट गेट्स म्हणतात, त्याची ओपनिंग आपण कंट्रोल करून स्पीड ऑफ वॉटर वी आर गोइंग टू कंट्रोल ओव्हर देअर. ओके, then compare Francis turbine and Kaplan turbine. आता Francis turbine and Kaplan turbine both are reaction turbine. Francis turbine पण reaction turbine and Kaplan turbine पण reaction. But there are certain differences. What are these differences? Type. So in case of Francis turbine, my water flow is axial. Water flow is axial or mixed flow. But in case of your Kaplan turbine, my water flow is in case of your Francis turbine, the water flow is radial. वॉटरचा फ्लो आहे तो रेडियल इनवर्ड आहे. ओके, आणि किंवा मिक्स फ्लो आहे. पण इन केस ऑफ कॅप्लॅन टर्बाईन इट इज ॲक्सियल फ्लो टर्बाईन. डिस्पोजिशन ऑफ शाफ्ट, फ्रान्सिस टर्बाईन मध्ये व्हर्टिकल किंवा हॉरिझॉन्टल असू शकतं. कॅप्लॅन टर्बाईन इज ओनली व्हर्टिकल. ओके, शाफ्टची पोझिशन फक्त व्हर्टिकल असेल कॅप्लॅन मध्ये. फ्रान्सिस मध्ये ते मे बी व्हर्टिकल असू शकतं किंवा मे बी हॉरिझॉन्टल पण असू शकतं. नंबर ऑफ वेन्स, फ्रान्सिस टर्बाईन हॅज मिनिमम 16 and maximum 24 veins. Okay, for guiding the water. So Francis turbine consists of minimum 16 to maximum 24 veins, and in case of Kaplan turbine I have only 3 to 8 veins. Adjustment of runner vane. A Francis turbine has fixed veins, so it is not adjustable, and Kaplan turbine have movable, so it is adjustable. So Francis turbine is used for medium head, Kaplan turbines are used for low head application. 3 meter to 30 meter only. Flow rate. So Francis turbine have medium flow rate. The amount of quantity of water required is less over there. In case of your Kaplan turbine, it requires very high flow rate. Okay, so specific speed 52 to 50 rpm. And in case of Kaplan turbine, it is 250 to 800 rpm. Types of generator: regular generator is Francis turbine, and Kaplan turbine uses the heavy duty generator. So these are certain differences over there. Now, which type of generator is used in the hydroelectric power plant. Before going for this, I will just show you certain video over there in which you will find out the applications of this one. Just wait.
Today we will discuss about impulse turbine and reaction turbine. So as we know, the turbines are classified according to the hydraulic action. First one is the impulse turbine and second one is the reaction turbine. So firstly we know the main components of this turbine. These are the runners which are used in both the turbines. These are the stationary guide wires which are mounted on the runner of the reaction turbine.
So if you are going to observe,
And in case
of reaction turbine, you are
buckets
going to
are
use such
mounted
type
on
of
the
guide vanes. And in
surface
case
of
of
the
your
runner.
impulse turbine Pelton wheel, you are going to use the buckets. These are the buckets. Okay.
This is the moving nozzle in case of reaction turbine, and in case of impulse turbine here is fixed nozzle.
Okay, so in case of reaction impulse turbine, you are going to
Now
use
we
the
can see the
nozzles.
path of the
The
water
nozzle will
that
increase the
strikes
pressure.
on the buckets of the impulse turbine runner, and this is the water that is coming out from the moving nozzle, and this is the water that is discharged from after striking to the bucket to the tail race, and this is the tail race. And as we can see that water is coming out from the fixed nozzle and strikes on the buckets of the runner of the impulse turbine, then it will starts to rotate.
So you can see the rotation of your buckets.
So here
As the water
pressure
jet
energy of
falls on
water
the
is
buckets,
converted
that
into
causes the
kinetic
moment.
energy
It
of
will push
water.
the buckets in
So
opposite
in
direction.
impulse
Similarly,
turbine,
this also
the
pushes the
potential
bucket.
energy
So that
overhead
causes the
is
rotation.
completely
And this is the
converted
shaft. To
into
this shaft, you are
kinetic
connected the
energy
alternator.
by passing the water through the nozzle, and water jet comes out at higher velocity at atmospheric pressure. So the free jet strikes the buckets mounted on the runner, and runner is rotated, developing the mechanical work. So as we know, this is the shaft of the runner that is coupled with the shaft of the generator, and it hydraulic energy of water converted into mechanical energy. And from here, when it will starts to rotate, the shaft of generator starts to rotate, and generator produces the electricity. And in case of reaction turbine, here is the moving nozzle. Here the part of total head available is converted into kinetic energy, and the rest remains in the form of pressure head or pressure energy. And the pressure of water entering the turbine is always above atmospheric pressure. So as the water flows through the turbine, its pressure also changes. As the flow of water from the inlet to the tail race remains under pressure, and this turbine is completely closed by a casing, and a tube connected at the outlet of turbine to the tail race is known as draft tube, and the purpose of that draft tube is to raise the effective head acting on the turbine. But there is no need of any type of tube or draft tube in case of impulse turbine, because here it is working at atmospheric pressure. But in case of reaction turbine, here is the variation of the pressure. So to maintain the effective pressure, effective head, here is the need to use a tube, that is draft tube. Pelton turbine, Gillet turbine, Bunke turbine, these are the example of an impulse turbine. Francis turbine, Kaplan turbine are the example of reaction turbine. So today we learned the difference between the impulse turbine and reaction turbine, and working of impulse turbine and reaction turbine.
So basically, this is the Kaplan turbine.
Kaplan turbines are suitable for power extraction when water energy is available at low head and high flow rate. which means they are suitable for operation when water is stored in a big reservoir at a relatively shallow altitude. In Kaplan turbine, flow is entered through a spiral casing. Decreasing area of casing makes sure that flow is entered to the central portion, almost at uniform velocity, throughout the perimeter. Water after crossing the guide vanes, passes over the runner. Finally it leaves, through a draft tube. Most important part of Kaplan turbine is its runner. Cross-section of runner blade will have a curved shape. When water flows over it, it will induce a lift force due to airfoil effect. Tangential component of lift force will make the runner rotate. This rotation is transferred to a generator for electricity production. Kaplan turbines are axial flow machines, where absolute velocity of flow is parallel to axis of turbine. Water is precisely made to pass through runner blades, with help of a shroud. Power demand may fluctuate over time. A governing mechanism, which controls position of guide vanes, is used to control water flow rate.
So you just observe over
This
how
can
the
meet the
guide vanes
varying
will
power
control the
demand.
flow of water. They are going to open and close the when
Blades
the
of
guide vanes are
Kaplan turbine
completely
are
open, more
designed to
water will
operate
go
under
inside
a
the
wide
turbine.
range of
And
operating
when the
conditions.
guide vanes are going to be
A
closed,
rotating
the opening
blade
is small, so the
experiences
space
relative
space
velocity of
available for
flow.
flow of water will decrease and less amount of
The
water will
fundamental
flow to
thing in
the
blade design is
turbine.
relative velocity of fluid flow should be at optimum angle of attack at all cross sections. Even though absolute velocity is axial, relative velocity will be inclined, depending upon blade velocity. Inclination of relative velocity increases as we move from root to tip, due to increasing blade velocity. There should be continuous twist in blade, from root to tip, so that at every cross section the angle of attack is optimum. With varying flow condition, relative velocity will change drastically. Kaplan turbine blades are adjustable. When flow rate is high, relative velocity of flow will be more axial, so blade should pitch vertically. If flow rate is low, relative velocity of flow is more tangential, so blades are pitched in tangential direction. In short, pitching action of blade makes sure that blade is still in optimum angle of attack, even under varying flow. Apart from controlling the flow rate, guide vanes have got one more function. They help in controlling swirl of flow. If guide vanes were not present, the flow would be highly swirling in nature, due to its tangential entry. Such a flow would reduce performance of turbine drastically, due to its poor angle of attack. So guide vanes control swirl of flow, for optimum angle of attack. Biggest challenge in design of Kaplan turbine is how to overcome problem of cavitation, which causes material erosion and vibration. Cavitation is unavoidable in Kaplan turbine, since in most of the regions, pressure goes very low. But damage due to cavitation can be reduced by using suitable blade material, and use of anti-cavitation fin. Draft 2, which transforms dynamic pressure to static pressure, due to its increasing area, also helps in reducing cavitation effect. Thank you. Hope you got a good...
Welcome to the video tutorial. Welcome to the video tutorials of Mechanismuller.
So see, this is the
This
Francis
animation
turbine.
authored by Dr. Sehan Ersoy is the property of the client GDF Suez and subject to copyright limitations. We thank GDF Suez for giving us the permission to publish this video. There are three major types of water turbines. The Pelton turbine requires large water head and low flow rate, and the Kaplan turbines require low water head but large flow rate. The Pelton turbines usually build in mountainous regions, while the Kaplan turbines are located in lowlands. These restrictions make these two-kind turbines less common than the Francis turbine. The Francis turbine fills a large gap between the Pelton and Kaplan and it is widely used. They operate in water head from 10 to 600 meters, and primarily used for electric power generation. Their power output can be calculated from the water head and flow rate and typically range from 10 to more than 700 megawatts. One of the distinct advantages of the Francis turbine with respect to other water turbine is that they can also be used as water pump. This makes them ideal for the pump storage systems. This animation shows the operation of a Francis turbine in a dam. The arrows show the water path and direction inside the dam. The water from reservoir behind the dam transferred to the turbine by a penstock. The penstock diameter of a Francis turbine could be as large as 10 meters. The water coming from the penstock is transferred to the inlet scroll, which distributes the water equally around the wicket gates. Water passes through the wicket gates, which controls the amount of water passing through the turbine, before reaching to the runner. This in effect controls the power output of the dam. Wicket gates also adjust the angle of the water reaching to the runner. After passing through the wicket gates, the water reaches to the runner. The water pressure forces the runner to rotate. The rotation speed of the runner can be in the range of 80 to 1000 revolution per minute. The water continues its motion downward under the runner to the exit pipe. The exit pipe discharges the water to the environment as low pressure water. The turbine shaft of the Francis turbines is almost always mounted vertically. This makes discharge of the water much easier due to swirling effect of the water in the inlet scroll and the effect of the gravity. The rotation motion of the runner is transferred to an electric generator shown in here. The generated electricity is converted to high voltage current and transferred to the grid to be consumed. One big advantage of the water turbines is that power output can be regulated very easily. If the demand is reduced, the amount of water flowing to the turbine can be reduced relatively short period of time. We thank our client GDF Suez giving us the permission to publish this video.
Okay, then we will just discuss the examples comparison. Okay, the working of Francis turbine.
Pelton, Francis, and Kaplan are the most commonly used hydraulic turbines. In this
So if you
video,
are going to
we
see
will
in
compare
Pelton wheel
these
turbine, this is my runner, and on this runner I have just placed the buckets either with the help of nut and bolt, or since sometimes I am going to use the casting also. The buckets are directly casted in the wheel. The wheel and bucket is a single unit, but for the large applications we are going to use the nut and bolts. So if the one bucket is going to be damaged, I can replace the single bucket. If it is a casting, then it is quite difficult for you to just repair it.
turbines and see when to use which turbine. When we move from Pelton to Kaplan, the force-producing mechanism changes from impulse to reaction. In Pelton, pure impulse force of water jet is responsible for rotation of impeller. Water stored at high altitude can produce high impulse force due to its high velocity. So Pelton turbine are suitable for operation when water energy is available at high head and low flow rate.
So if you are going to observe this one with this,
Whereas
we are going
Kaplan
to,
turbine
control the
is
flow
suitable
flow.
for the reverse case. A high water flow will guarantee efficient production of reaction force. So when water is available at high flow rate and low head, Kaplan turbine is the best choice. Francis turbine comes in between for medium head to medium flow rate applications.
See the complexity of the blades in case of Francis turbine.
Francis turbine is not a pure reaction turbine. A portion of force comes from impulse action also. This graph gives a clear idea about when to use which turbine, depending upon available water head and flow rate. It is obvious that Francis turbine covers a wide range of operating conditions, or they can work efficiently in wide range of operating conditions. This is why Francis turbine is the most preferred hydraulic turbine. If you use a turbine out of its recommended operating range, it will work, but less efficiently. It is also interesting to note the direction of fluid flow with respect to axis of rotation in each case.
Say, in case we have just discussed that in case of Pelton wheel turbine, the direction of your flow is tangential. Now, if you are going to see this one, the bucket is not a single spoon. Okay, it at the center, water is divided into at the center there is a projection. Water is divided into two parts. One part is flowing through this one, second part is flowing through this one. So it is a tangential flow over here. In case of this one, it is axial flow. Okay, so in case of your Kaplan turbine, it is axial flow and it is the radial flow. So it has the mixture of your tangential as well as axial flow. So as the design of these blades is very complicated over here, so this uses the aerofoil shape. Okay, so these are some turbines which are commonly used in practice. Now, the next part that is the important or is the generator. So basically, what type of generators are used for the hydroelectric power plants? So in most of the cases, I am going to prefer the generator which are AC alternators. Okay, because my in case of India, our generation is AC, or transmission is AC, and also distribution as well as consumption is also AC. So I will prefer the AC generator over here, and these are called as the alternator. And these are basically three-phase hydro generator. It is robust in construction, a separate. Now basically what happened, I need to convert mechanical energy into the electrical energy. Okay, but for the large applications I cannot use the permanent magnet as my permanent magnet, as all of you know, that the Faraday's law of electromagnetic induction. Okay, so we know the principle of generator. Whenever the magnetic line of forces are cut by the conductor, EMF is induced in the conductor, so I need a magnetic field. Okay, and how to produce this magnetic field? Magnetic field is produced naturally by the natural magnets. Okay, but the strength of this natural magnet is very low, less. So instead of using the natural magnet, I am going to use the electromagnet. And for creating the electromagnet, I need an exciter. I need some electricity. Okay, so electricity will produces the magnetic field. Now a separate exciter is given to separate alternator pole by DC generator exciter, which is mounted on the same shaft. So basically in the hydroelectric power plants, we have the alternator. Okay, and for alternator produce the magnetic field in the alternator, I need a DC exciter. Means a separate excitation is given by the separate alternator pole by the DC generator, which is mounted on the same shaft. It excites the field winding of generator. And what is the function of this one? It will excite the field winding of generator so that it will produces the magnetic field. Okay, to excite the main exciter, there is a pilot exciter which is a permanent magnet. And for exciting this uh, main exciter, we are going to use the pilot exciter that is made up of permanent magnet. Basically these are having very low capacity permanent magnet. The excitation voltage may be 110 volt, 220 volt, or 300 volt DC. My excitation voltage, if you are going to note down, the excitation voltage is 110 volt, 220 volt, or 300, and these are all DC. The generator voltage is 3.3 kV, 6.63 V, 11 kV, 17.5 kV, and 20 kV. Okay, So what is the output of my generator or alternator? My output of generator is might be 3.3 kV, that may be 6.6 kV, that may be 11 kV, that may be 17.5 kV, or it may be 20 kV. In most of the cases it is 11 kV. Okay, number of poles of hydro generator is more and is various from. Okay, so if you are going to consider the number of poles, so for hydro generator alternator is an n number of poles. Okay, that will vary from 6 pole to 120 pole, and the machine is of salient pole type. Okay, number of poles may be 6 to 120 and it is a salient pole. Hydroelectric generators has large diameter and small in length. They have the more diameter is large and length is small. The length of the shaft is small, but they have the large diameter. In case of alternator, coupled with the impulse turbine or horizontal. Okay, so if you are going to use the impulse turbine, that is Pelton wheel turbine. In case of Pelton wheel turbine, my generator is mounted in the horizontal configuration and its speed is 100 to 1000 rpm. Okay, so in case of Pelton wheel turbine, mounting is horizontal type and speed is 100 rpm to 1000 rpm. In case of hydroelectric generator with the reaction turbine, if you are going to consider the reaction turbine, okay, generator with reaction turbine, they are vertically mounted. Okay, so impulse turbine जर असेल तर आपण त्याच्यामध्ये हॉरिझॉन्टल माउंटिंग यूज करतो आणि रिएक्शन टर्बाइन असेल तर वर्टिकल माउंटिंग यूज करतो. Okay, and their speed is low, 20 to 500 rpm. Hydro generator is low speed machine compared to the steam turbine generators. Okay, if you are going to consider the speed of your thermal power generator, thermal power turbine, so in that case the alternator may have 3000 rpm, 1500 rpm or something, but in this case their rpm is a maximum 1000 and minimum 20 rpm. Then as my generating is rotating, so definitely there is a friction. Because of this friction there are losses that causes the increase in temperature. So machines are cooled. Cooling is necessary to improve the performance of the generator, so I need to use the cooling system for this one. Then protection against runaway, high speed is provided, over voltage, under voltage, so we need to use the multiple protection. Okay, your speed should not be crossed by maximum speed, otherwise the generator may get damaged. Then over voltage protection must be there. Okay, similarly overload protection must be there, and under frequency protection, overload protection as well as under frequency protection should be there. Okay, so these are the protections I am going to use for my generator. Over temperature protection is also required in some cases over there. The main protections provided to the generator, these are the various types of protection. This questions is commonly asked in the interview: what are the protections used for the electric generators or alternator? So at that time you should be able to mention this protection. These protections are protection from the over speed, high speed, over voltage protection, overload protection, under frequency protection, and over temperature protection. Now, what are the advantages and disadvantages of hydroelectric power plants? So advantages are what? As we are not going to use any fuel, so the no fuel cost, because water is available free of cost in the nature. So I am going to just simply store the. But here the cost of storage of water is required. For that purpose, I need to construct the dam. So its cost will be increases. But my fuel cost is zero. In case of your thermal power plant, you need to purchase the coal. Coal is a fuel. In case of diesel power plant, you need to purchase the diesel. The cost of diesel is very high, 80 rupees per liter. Okay, in case of nuclear, we need to purchase the nuclear radioactive elements such as uranium, thorium, plutonium. Okay, so the cost will increases over there. But in case of hydroelectric power plant, you are going to use water as a fuel. So water is easily available, so it cost is comparatively less. There is no fuel transportation cost. Okay, as in case of thermal power plant, I need to transport the coal from one location to another location, so the transportation cost will increases. In case of nuclear power plant, I need to carry the nuclear fuels such as radioactive elements from one location to the nuclear mines to the nuclear generating station. So the cost will be there. In case of diesel, I need to carry the diesel from one location to another location. But in case of water, hydroelectric power plant, I have stored the water at the same location where my plant is located, so my cost will be less over there. There is no necessity of fuel and ash handling equipments, as there is no burning. Okay, so my fuel and ash handling equipments are not required in this case. There is no pollution, इथं कुठल्याच प्रकारचं बर्निंग होत नाही, गॅसेस इमिट होत नाही, त्यामुळे पोल्युशन नाहीये. There is no air pollution, soil pollution, or water pollution also. Okay, it is very neat and clean plant. Okay, it does not emit any gases or it does not causes any ash, so it is a neat and clean plant. Operating and maintenance cost is very low. Just wait. हाँ सर. ठीक है, मुझे मैं कॉल करके देखता हूँ, मेरे 2 मिनट में कॉल करता हूँ, लेक्चर चल रहा है. Okay, so its operation maintenance cost is very low. If you are going to see the devices, thermal power plant मध्ये किती components use होतात? n number of components. Okay, nearly 50 to 100 components, different components are going to be used. Hydroelectric power plant मध्ये major component काय आहे तुमचं? Walls आहे, turbine आहे आणि generator. या व्यतिरिक्त कुठले components आहे? But in case of thermal power plant, we have स्टीम से कोल्ड हँडलिंग प्लांट, त्याच्यामध्ये कन्व्हेअर वगैरे सर्व सिस्टीम आहे, बॉयलर आहे, त्याच्यानंतर तुमचं सुपर हिटर आहे, त्यानंतर इकॉनॉमायझर आहे. ओके, एअर फ्री हिटर आहे, त्याच्यानंतर वॉल सिस्टीम्स आहेत, परत त्याच्यानंतर टर्बाईन्स आहे आणि नंतर जनरेटर आहे. सो नंबर ऑफ कंपोनेंट्स आर मोर, सो डेफिनेटली द ऑपरेशन अँड मेंटेनन्स कॉस्ट विल बी more in thermal power plant. But in case of hydroelectric power plant, as there are less number of components, so its operation and maintenance cost is very low. Hydropower plants can be put into service immediately. Okay, so this is very important. For starting the thermal power plant, I need minimum 12 hours to 48 hours for large capacity, but with the same hydropower plant having the same capacity, I can force into the working within few minutes only. There is no standby losses. In case of hydroelectric power plant, there is no standby losses. Efficiency of the plant is highest and does not change with age. If you are going to compare the efficiency, okay, as in case of thermal power plant, the efficiency will decreases with the age. Okay, but in case of hydroelectric power, the efficiency, it's most, it will give you the maximum efficiency among all the plants, and it does not change with the age, whether it is 2 years, 4 years. In case of thermal power plant, as the aging is there, the efficiency will decreases. Power generation can be controlled quickly. In case of hydroelectric power plant, just by simply opening and closing of the valve allows the less or more water to go inside the turbine, and you can change the rotation of your turbine. Okay, so you can easily control the flow of water, so you can easily control the power generation, okay, without any difficulty. But in case of steam power plant, steam pillars power plant, it is quite difficult for you to control the power generation quickly. It requires some time for controlling the power generation. This plant is suitable for supplying power to variable load. Okay, so this power plant will supply the power to variable load because your load is continuously varying. So if my load will increase, I can quickly increase the amount of water flowing to the turbines or going through, so that I will increase the generation. If my load will decrease, I will just close the wall and just control the amount of water flowing through that, so my speed of will generate decreases and power generation decreases. So variable load can be easily handled with the help of hydroelectric power plant. By controlling the discharge of the water precisely, constant speed, constant frequency can be maintained. So in this case, I can easily maintain the constant pace and constant frequency. For that, simply what I have to do, I need to control the discharge of water. Okay, precisely. The life of this one is the longest one. Okay, its life is nearly more than 30 years to 50 years. The generation cost per unit is the lowest. If you are going to consider the generation cost per unit, this will provide me the lowest generation cost per unit with minimum losses. So and minimum pollution कुठल्याच प्रकारचं होत नाही आहे, लॉसेस पण कमी असतात आणि जनरेशन कॉस्ट जी आहे ती सर्वात कमी आहे. सो इट इज कम्स अंडर द ग्रीन प्लॅन. Okay, green energy generation. In addition to generation of electrical energy, it is useful for supply of drinking water. ओके, हायड्रो पॉवर प्लांट इलेक्ट्रिसिटी जनरेट करतेच आहे, पण त्यासोबत काय करते, तुम्हाला पिण्याकरता पाणी मिळतं, इरिगेशन करता शेताकरता पाणी मिळतं आणि फ्लड जे पूर वगैरे येतात त्याला कंट्रोल करतं. सो दीज आर द सर्टन अदर बेनिफिट्स ऑफ हायड्रोइलेक्ट्रिक पॉवर प्लांट्स. सो दॅट्स वाय हायड्रोइलेक्ट्रिक पॉवर प्लांट्स आर कॉमनली यूज. Basically, each has advantages, similarly it has disadvantages also. So main disadvantage is what? Its capital cost is high due to construction of dam. हायड्रोइलेक्ट्रिक प्लांट सेटअप करण्याकरता तुम्हाला डॅम कन्स्ट्रक्ट करायला लागतो आणि डॅम कन्स्ट्रक्ट करण्याची कॉस्ट जी आहे दॅट इज इन मिलियन्स ऑफ रुपीज और बिलियन्स ऑफ करोडोमध्ये ते कॉस्ट जातं. दॅट मे बी 3000 करोड, 4000 करोड, बिकॉज यू हॅव टू जस्ट स्विच. ओके, वी नीड टू रिलोकेट द विलेजेस which are coming under the influence or in the backwater side. Okay, so that it cost of construction is very high and time required for constructing the dam and establishing the power plant is also more. It depends on the nature. It depends on nature as it requires huge amount of water which is stored during the rainy season. So in some cases, in the particular, you are not reliable on this one because every years the monsoon pattern will change, and if in some years there is not a proper monsoon, आपल्याला पाहिजे तेवढा पाऊस जर नाही पडला तर त्याच्यामध्ये आपण we are not able to store the water, and at that time we are not going to use the my hydroelectric power plant to its full capacity. Firm power is totally depend on monsoon. Okay, my output of this dam is totally depend on the monsoon. It takes long time for completion, erection of the power plant. As we already discussed that, it takes the time from 10 years to 15, 20, 30 years also. Because the time required for construction of the dam and all these government processes is quite large. It requires large catchment area for storage of the waters, and this is also a problem because we need to relocate certain villages or the towns which are coming in the way of your rivers or in the back catchment area, as sites are away from load center, so the transmission cost will be more. This is one major disadvantage, as my power plant is located away from the load sensor, so the cost of transmission is more. Losses are also losses. Which losses? The energy transmission losses, transmission distribution losses are more in this case. Okay, so this is all about your hydroelectric power plant. Okay, do you understand this thing?